guys, happy Monday. Welcome back to another week of math. So this week is going to be all review. We are going to be going over everything that we've learned so far this year. Each day will be broken up into a new subject of math. So today we'll be working on multiplication and division. We'll also see word problems this week, fractions, and area and perimeter. It's really important that we're watching all the videos and taking as many notes as you possibly can this week. Next week you do have your final for the third grade math test. So a lot of this will be on it. And it will also be on your assignments for today, whether you're doing paper-based or on Edulastic. So I just wanted to get started by going over all of the properties of multiplication, what they look like, how to use them, and then we'll finish off our video today by working on flipping multiplication to division and division into multiplication so that we can solve problems that we might not already know. So to begin, we are going to start with the zero property of multiplication. The zero property of multiplication just goes over any number times, so let's say 4 for example. 4 times 0 is always going to be 0. So the zero property is just showing you that any number times 0 or multiplied by 0 is always going to be 0. The identity property is essentially saying any number multiplied by 1 is going to be that same number. So if I took 7, sorry, I'm trying to do this so everybody can see, times 1, our answer is going to stay at 7. So the identity of the number is going to stay the same and it is not going to change. Same with 10 times 1. It will always be 10 because it will always be whatever number you are multiplying by. When you multiply by 1, the number always stays the same. The commutative property, a lot of us in class know this as the flip-flop property. So again, if I have a number such as 5 times 2, the commutative property of multiplication is going to say that this same problem right here is equal to itself. But again, we just flip the numbers. So instead of saying 5 times 2, we would say 2 times 5. And we know that both of those answers equal 10. Another example of this would maybe be something like 8 times 3. Well, the flip-flop of that, if you'd like to write it down, you can, is 3 times 8. So again, your number just flips the order you put it in, but they will still equal the same exact number. The associative property of multiplication is when you have 3 numbers and you multiply them together. So let's say I have 2 times 1 times 3. I'm going to put parentheses around 2 times 1. Remember, parentheses help us determine the order that we multiply in. Well, the associative property says that this same equation, 2 times 1 times 3, you can write it again, and it would still stay, the same if you put the parentheses around 1 times 3. So the associative property is the same numbers on both sides of the equation, so 2, 1, 3, 2, 1, 3. The order in the parentheses just changes. So you'll see here I have it around 2 and 1, and here I have it around 1 and 3. But remember, again, like I said, parentheses tell you that that is what you need to multiply first. So if I multiply 2 times 1 using the identity property, that's going to be 2, and then 2 times 3 is 6. Well, when I do it over here, I have to start with what's in the parentheses, and that's 1 times 3. Again, using the identity property, I know that that is 3. And then 2 times 3, I'm trying to get you to see that, 2 times 3 is equal to 6. Again, now this equation becomes the commutative property because the numbers are just reversed, but you have the same answer. So here was 2 times 3, and here was, oh, I guess it still looks like 2 times 3, but if I reverse it, it would say 3 times 2, and that still equals 6. Now the distributive property, you're going to see this a lot when we are using arrays or pictures. It's easier to break it apart when you're visualizing it. The distributive property is always helpful when you're multiplying by bigger numbers that you might not know how to multiply by yet. So for example, I am going to use 8 times 4. If I didn't know how to multiply by my 8s yet, I could break this apart into 2 smaller numbers that add to equal my bigger number. So in other words, I could break this apart maybe into 5 and 3, because I know that 5 plus 3 equals 8. So now what I would do is I would multiply each of these numbers by 4. So my equation would look like this. 5 times 4, just like that, but I'm not done yet, plus 3 times 4. So one number in the distributive property always has to stay the same, and it's normally the smaller number. So in this case, 4 was the smaller number out of 8 and 4, so I kept that number the same. 5 plus 3 equals the original number of 8. That is why this equation would work. So 5 times 4, just to check my work, is 20, plus 3 times 4, which is 12. When I add those two together, that is 32. And if we counted by 8s 4 times, that would also get us to 32. So this equation works. I will show you how it would look if it was an array. That might help us visualize it. So if I had 1, 2, 3, 4, 5, 6, 7, 8, and then 4 going across in each, instead of counting each one of these, sorry, I'm almost there. Instead of counting each one of these dots, so again I have 8 going down, 4 going across, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4. So this picture right here matches my original 8 times 4. I could now break the 8 apart into 5 and 3. So what I would do is I would go 1, 2, 3, 4, 5, and then I'm going to draw a line. And then you're left with 1, 2, 3 at the bottom. So again, 5 plus 3 equals the original 8, and my 4 stayed the same going all the way across. So that's just another way to represent the distributive property. And again, if this is 5, this is 4, this is 3, and then that bottom part is 4, I'm trying to write it so you can see it, you would multiply 5 times 4, 3 times 4, and add both of those answers together to get your total of 32. So I will back this up a bit, so if you'd like to take notes on this, feel free to. I would like you to pause though, because I am going to erase. If you are taking notes, please pause so that I can erase, and we are going to go and move on to flipping multiplication to division and division to multiplication. Okay, so I'm going to erase now. Sorry. Alright, so when we flip multiplication to division, we're doing this to help us divide. So, let's say I have, recenter you, let's say I have 3 times 4, and I need to figure out what that equals. Well, a lot of us could count by 3s or by 4s to figure out that the answer is going to be 12. So I know that 3 times 4 is 12. But now I'd like to turn this into a division problem. So the way I turn this into a division problem is I take the biggest number, which is the answer of multiplication, and it becomes the beginning number of division. I then put my division sign, or my divided by sign, and I'm going to take the 3, the first number of multiplication, and then my answer is going to become this second number. You could also flip it and use the commutative property of division and say that 12 divided by 4 also equals 3. Now this one we took a multiplication problem and we turned it into division. But if we were given a division problem, let's say 20 divided by 5 equals what? And we needed to figure that out, but we didn't know how to solve this problem. We could flip this problem to multiplication. So, just like your biggest number here in division was the answer to a multiplication problem, you are going to write that. The biggest number in the division problem becomes the answer in your multiplication problem. This number right here then becomes your first number. You put your multiplication sign and you have a blank. So now I can count by 5s until I get to 20. So 5, 10, 15, 20. I skip counted 4 times to get to 20. So that means 5 times 4 equals 20, which also means that 20 divided by 5 equals 4. And that's how we're going to flip it to multiplication. Another way to figure out this answer would be to draw 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20 dots. And we know that it's in 5. There is 5 in each group. So what you would do is you would go 1, 2, 3, 4, 5. Draw a circle around those. 1, 2, 3, 4, 5. Draw another circle around that. 1, 2, 3, 4, 5. Another shape around that. 1, 2, 3, 4, 5. Another one around that. When I count these, I have 1, 2, 3, 4 groups of 5 circles. So again, the answer is still 4 because you have 4 groups with 5 dots in each. So that is how you flip a multiplication problem to division and how you flip division to multiplication. If you have any other questions, please let me know and I'd be happy to jump on Google Meet to help you out. I hope you have a great rest of your day, and I'll see you back tomorrow. Bye!